In this video, we are going to talk about section 2.3 from the book, okay, which is about the product and the quotient rule. Also, we'll talk about the higher order derivative, okay. So in the last video, we talk about the derivative rule or the differentiation rule, okay. So what is the difference between differentiation and the derivative? So derivative is the one that we learned with that definition, right? That's the derivative of a function, okay? But the differentiation is basically the process of finding the derivative. Basically, they are the same thing, okay? The process of finding the derivative is called the differentiation. So we saw that the definition of y prime is f prime of x. Y prime or f prime of x is limit h tends to 0 f of x plus h minus fx over h. So in section 2.2 we saw many examples on finding the derivative without using the limits, right? We use the shortcut method to do that. But whenever you are trying to find out the formula of something, if you are trying to find out formula of some for the derivative of a function, we will have to use that limit definition again. But all the examples we did in section 2.2, they are very simple functions, okay? So some of the rules that we did was the derivative of x to the n is n times x to the n minus 1. Some other rules are derivative of constant is 0, right? The derivative of the sum of the functions is basically you can distribute the derivative. The derivative of the sum of the function is sum of the derivative, basically, right? Do you remember that we were doing basically f plus g prime. If there is a derivative of the sum, it is same as f prime plus g prime. And if there is minus, okay, if there is minus, then there will be minus as well, okay? If there is a constant times the derivative, right, we also did k times f prime. If there is a constant times a function, and if you're finding the derivative of that, it is same as k times f prime. You can pull that k out and find the derivative of f prime only. So we saw all these things. Also, the derivative of sine x was cosine x, derivative of cosine x is negative sine x, and so on. Okay, that's what we did. But none of the example we did had the product. Okay, for example, if you want to find the derivative of x squared times sine x, we don't have done that any problem. We have not done any problem of that type, okay? So to handle this type of problem, we need a formula for the product. So it is called the product rule, the derivative of fx times the gx. How do I find out that? Let's derive the formula first. What I'm going to do here is, so this is the limit definition, right? When you are finding the derivative, it is limit h tends to 0. That all the x in this function will be replaced by x plus h, and then do minus, and then just write down that one, right? That's what we're doing here. To find out the derivative of this, y prime is limit h tends to 0. All these x are replaced by x plus h, that which is f of x plus h minus times g of x plus h. Minus, just keep that same thing, write down that same thing, fx times gx divided by h. So what I'm going to do next is basically limit h tends to 0, okay? I want to write the first term f of x plus h times g of x plus h, okay? And I want to leave little space in the middle, and I want to write the last term only. So minus f of x times g of x divide by h. I'm going to use a little trick here, okay? So what I'm trying to do here is I will add and subtract something there. So that will be minus fx times g of x plus h plus fx times g of x plus h. Why did I do that? You will know that later. But adding and subtracting the same thing does not make any difference, because if you these are the same thing, right? If you cancel that, you will get exactly the same thing. But I am adding and subtracting something just to use the limit definition of the derivative, okay? Now let me group the first two terms and the last two terms, and then see if there is anything common, okay? So what is the common on the first term and the second term? G of x plus h. Let me do that. So it is limit h tends to 0, f of x plus h minus f of x, okay, and then times g of x plus h. I'm taking g of x plus h out, okay, and then plus, what is the common in the third and fourth term? So fx is common, right? Fx times g of x plus h, okay, minus g of x. This is what we get, and whole divide by h. The next thing I want to do is I want to split that h to the first term and the second term, okay? So let me do that. Limit h tends to 0, f of x plus h minus fx, okay, and then times g of x plus h over h, plus I want to do the limit again, h tends to 0. I'm splitting that limit as well, okay, or I'm distributing the limit as well. F of x times g of x plus h minus g of x divided by h. You see that? So when you take h tends to 0, do you know how much is this value? How much is that value when h tends to 0? This is basically f prime, right? And how about that one? That will be basically g prime. Also, when h tends to 0, this will be just gx, right? So basically what you get there is, when you take a limit and then when you put h tends to 0, you will get f prime of x times g of x, right? And then plus f of x times g prime of x. This is basically the value of y prime, right? In other words, what is our y? Y is basically f times the g, right? So if you have f times g, and if you want to find the derivative, that the prime derivative of f times g, then it will be f prime times g plus f times g prime. So keep this in mind. You cannot distribute this derivative to the product. It is not equals to f prime times g prime. This is not equals to f prime times g prime. Never make these mistakes, okay? So the derivative of f times g prime is, what you do is you find the derivative of the first function and then do times the second function, write as it is, and then do plus, write the first function and then times the derivative of the second function. So you'll have to find the derivative of these functions term by term. When you take the derivative of the first one, you keep the second one without the derivative, okay, and so on. In the book, if you look at the book, you will see not in terms of f and g, but in terms of u and v. In the book, in the first 2 pages of the book, they have the formula. Then they have written that formula like this: u times v to the prime is equals to u prime times v plus u times the v prime. They have written this formula. Again, these formula are called product rule, okay? So these formula are called the product rule. So now we will do some examples, okay? Some of the examples on how to use the product rule to find out the derivative of a function, okay guys? So let us look at the first example. So the first example here is basically the simple product of the two functions, right? U and then v. So fx is u times v. You see that? What is the formula of u times v? The derivative of u times v, it is u prime times v plus u times v prime. I just copied from here, right? What is u prime? The derivative of x squared is 2x times v is sine x plus u is x squared times the derivative of v is v prime, that is cosine of x. So if you want to be more specific, what is the common on this term and that term? Just x, right? You cannot take that x in the angle out. That is, you cannot take that out. So that will stay sine x and cosine x. Only the x there is x squared, there is x. I'm taking that x out. So what is left is 2 sine x plus x cosine of x. That is the final answer. Okay guys, on the second example, there is product of x to the 8 and cosine x. Also there is product of 2 secant x times sine x. Okay, so how can I do this? It's basically use the product rule twice. On the first one, there is u times v. On the second one also, there is u times v. We use the formula separately, okay? So what do you get here? You get u prime is 8x to the 8 minus 1 is 7 times, keep the cosine x as it is, plus x to the 8. U times v prime is negative sine x, right? That's what I get. Plus, now this 2 is just a number, so you can keep that out. Because you see, if you are finding the derivative of k times the f, you can take k out and find the derivative of f only. So you are finding the derivative of secant x times sine x only. So u prime is secant x times tangent x, right? And then times v is sine x plus secant x times, what is the derivative of sine x? Derivative of sine x is cosine of x, right? That's what you get. Let us simplify. Can you factor out anything from the first two terms? It is x to the 7, right? Let me take x to the 7 out. What is left is 8 cosine of x, and there is minus x sine x. Does that make sense? Because there is x left and there is times negative sign. That will be negative x sine x, right? And then plus 2. I want to write in sine and cosine. It will be 1 over cosine of x, because the reciprocal of sine is, cosine is secant. Reciprocal of secant is cosine, like that. So it is sine x over cosine of x. It is sine x plus this is 1 over cosine of x times cosine of x. Okay, you see that this cosine x divided by cosine x is 1, right? And similarly, this one will be sine square x. If you multiply that, this will be cosine square x. Okay, guys. So how would that look like if you write in that form? It is x to the 7 times 8 cosine of x minus x sine x, right? And then plus 2 sine square x over cosine square x, and then plus 1. You see that? So how that look like? You write down the x to the 7 as it is, x to the 7 and then times 8 cosine x minus x sine x as it is, okay? X to the 7, 8 cosine of x minus x sine x plus 2. What is sine square over cosine square? That is tangent square x plus 1. But do you know the relation between secant and tangent? Let me write down that if you don't know. We know that secant square x minus tangent square x is 1, okay? So if you add tangent square x on both sides plus tangent square x, you will get secant square x equals to 1 plus tangent square x, okay? This is tangent square x, okay, guys? So you can write this as tangent square x. So how would that look like then? So it will be, the final answer is x to the 7, 8 cosine of x minus x sine of x plus 2 secant square x. You know what? You could get this answer on right on the second line too if you simplify that before you find the derivative. For example, if you write secant x as 1 over cosine x, that will be sine x times 1 is sine x over cosine x. That will be tangent x. And the derivative of tangent x is 2 secant square. There is 2 already. So derivative of tangent x would be secant square x. So either way, you will get the same answer. Okay, guys. So, but there is one more question on this problem, right? It says f prime at 0. F prime at 0. How do I find out that? You plug, this is f prime of x, right? F prime of x. If you plug in x equals to 0, you will get 0 times something, that is 0, plus 2 times, it is 2 secant square 0. Secant 0 is 1. So secant square 0 is also 1. So 2 times 1 is basically 2. So this is also another answer. Now let us do the final example on the product, okay? So how do I do this is, see, look at this again. You want to find out the equation of the tangent line. Do you remember the equation of a line? If a point is given, this point is x1, y1. What it says is, find the equation of tangent line for fx equals to x minus 2 times x squared plus 4. Okay, any line has the equation y minus y1 equals to m times x minus x1. What is m? M is the slope. Slope is given by the derivative. Okay, so we will find out the derivative for the slope first. So what is the product rule here? Because it is x minus 2 times x squared minus 4. Since there is no exponent outside the parenthesis, you can FOIL it. Instead of using the product rule, you can FOIL it and use the regular derivative formula. But I like the product rule because it is, you don't have to FOIL it to do the product. Okay, so let us do that. U is x minus 2, v is x squared plus 4. Now the product rule is the derivative of u times v is u prime times v. U prime, the derivative of x minus 2, derivative of x is 1, right? And then minus 0. And then times v is x squared plus 4. That's what you get. Plus u is x minus 2. And what is the derivative of v? The derivative of x squared is 2x plus 0. Okay, so what you get is basically x squared plus 4. And the 2x plus 0 is 2x. Now you distribute that 2x with x minus 2. That will be plus 2x squared minus 4x. So look at these like terms, okay? So this term and that term are the like. So how do I combine them? It is 3x squared. X squared plus 2x squared. 3x squared minus 4x plus 4. That is the slope, or the slope function. Okay, now what you want to do is, but you want to find out the slope at a point, because m is slope at this point. So x is 1, y is negative 5. So you will have to plug in 1 for the to get the number for numerical value for the slope. It is 3 times 1 squared minus 4 times 1 plus 4. You see that? What is 4 times 1? 4 times 1 is basically 4, right? So negative 4 and positive 4 will cancel out. So 3 times 1 square is basically 3, right? So this is 3. So what is the equation of the line then? Y minus y1 equals to mx minus x1. Let's plug in y1 is negative 5, x1 is 1. So y minus negative 5 equals to 3x minus 1. So this is positive 5, right? So if you add 5, so subtract 5, y plus 5 equals to 3x minus 3. Subtract 5. If you subtract 5, what do you get? Y equals to 3x minus 8. That is the final answer for this example number 3. Okay guys, thank you.